Hello students and welcome back to this new session. In this session, I am continuing with the module 4 as we were discussing the numerical solutions of linear differential equations, various methods on that. One amongst them we have already learned in my previous sessions, that is Taylor series method. I hope that is clear to all of you. Now in this session, I am going to introduce to you a new method, that is modified Euler's method. Okay, commonly you pronounce it as Euler's method. Let us see how we'll solve the problems using this method. Step by step, let us understand how do we use the formulas and how do we implement them to solve them in the problems. Okay, let's see one by one. So firstly, suppose that the given differential equation is dy by dx is equal to f of xy with y of x naught is equal to y naught initially. Okay, let there be any differential equation with the given initial condition to you. Okay, so and you are supposed to work for y at x is equal to x1. Your x1 is x naught plus h. Okay, your x1 is x naught plus h. Okay, so first what we do, we apply Euler's formula to work for the initial value of y, or initial approximation for y we evaluate by Euler's formula. So Euler's formula we'll write here first, then we'll learn what is Euler's modified formula. Okay, Euler's formula. So these formulas are directly for you. They are direct formulas and you are just going to use them in your problems and solve. Derivations and all is not there in your syllabus. So just you have to remember the formula and apply them in the problems. Okay. So by first see here, I hope the point is clear. This is going to be the given differential equation to you. Okay, with the initial condition y of x naught is equal to y naught initially. And suppose that you are working for, y at x is equal to x1. Your x1 is x naught plus h. By Euler's formula, you are going to work for y initial approximation. I'm going to say y of x1 is equal to y1. Okay, so the value initial approximation whatever I get, I'm going to denote it as y1. Since it is an initial approximation, I'm going to raise it to the power 0 in the bracket. This means what? We are working for the initial approximated value for y1. We are working for the initial approximation for y1. Its formula is equal to y naught plus h times f of x naught y naught. Now what is this f of x naught y naught? You have f of xy. From there only you can work for f of x naught y naught. Just put x is equal to x naught and y is equal to y naught in that function. You will get f of x naught y naught. H value, it is nothing but, it is, yes, h is x1 minus x naught from this equation. x1 minus x naught. Y naught is already there. So you are going to work for y1 initial approximation using this formula. Now this is not going to be this is not the accurate result for it. We try to improve the result, or we try to get more accurate result by applying modified Euler's formula. So let's see what is modified Euler's formula. Okay, once we get the initial approximated value for y1, we are going to use it in our modified Euler's formula. Just see, our successive approximations for y, I am going to denote it as y1 first approximation. Earlier it was initial, so raised to 0 it was. Now it's going to be the first approximation for y1. y1 first approximation, y1 initial approximation, y1 first approximation. I hope that is clear. So this is the first successive result or accurate result for first is h by 2. It is similar to the Euler's formula only, but slight difference in that. I'll tell you how to remember it. It's very simple. So Euler's modified formula is y1 first approximation is equal to same y naught, but in place of h here h by 2 comes. F of x naught y naught you had, but here they are going to be two functions. Okay, two f's. Same functions, but here you are going to work for f of x1 comma y1 initial approximation. Okay, since there are two f's, so h is divided by 2. That way you can remember just the method. Okay, now similarly, once you evaluate this, you are going to work for y1 Second approximated value, y1 second approximation, y0 plus h divided by 2, f of x0 y0 plus f of x1 comma, recently you had evaluated y1 first approximation, you are going to use it here. Okay, you are going to use it here like this, x1 comma y1 first approximation. Okay, similarly y1 third approximation also you can evaluate. F of x0 y0 plus f of x1 y1 second approximation you are going to put. Okay, so means what, you are going to do certain iterative steps, that is previous value you will use it in the next step. Okay, these are called iterative steps for modified Euler's method. Okay, so and so on, you can apply the formula as long as you want to get the more desired, the more accurate result. I mean to say, the more accurate result, the more number of steps you do, the more accurate result you get. Okay, so let's see with the problems, it will be still clear. These are two important formulas. This is very simple, and once you write the first one, the rest you can follow. Okay, it's not that difficult, and they are once Euler's formula or Euler's modified Euler's formula. They are both are similar. Okay, so y0 h by 2 comes because there are two functions, two f's you are using. That concept, I hope that is going to help you to remember. Okay, so let's see with the problems. So here is one problem for you. Use modified Euler's method to find y of 0.2 given dy by dx is equal to 3x plus half y with y of 0 is equal to 1. Taking h is equal to 0.1. Perform 3 iterations in each step. Okay. Now let's see how to solve this problem. All of you take pen and a paper and start working for the problem with me. Okay. Now see here, let us take the given equation first. First step should be just take the given equation. You have dy by dx is equal to 3x plus 1 by 2 into y. Now this itself is your f of x, y. Keep it aside. Okay. Now what else is given to you? Y of 0 is equal to 1. Means what? Your x0 is this bracket inside. Okay. x0 is 0. Initial value for x is 0. Correspondingly, what is y0? It is 1. Now it's already been given. Taking h is equal to 0.1, take h as 0.1. Okay. So what should be x1 for you? x0 plus h, is it? x0 plus h. So x0 is 0, h is 0.1. So you get x1 to be 0.1. Means what? If you work for this problem by first this, you are going to get the value for y of 0.1. Is it? Because look at this. x1 is 0.1 here. Taking h as is equal to 0.1. Had you taken h is equal to 0.2, you would have directly got x1 to be 0.2 and you would have got the result directly. But in the question, he has said taking h is equal to 0.1. So you are going to take h as 0.1 only and work for 0.1. Okay, so this problem is going to be of 2 stages. Say this is stage 1. Because this stage 1 will end up with y of 0.1. Okay, but I want the result for y of 0.2. So means what? Taking this as the initial condition in my next stage, again taking h is equal to 0.1, we can get the value for y of 0.2 in the next stage. So this, let us denote this as stage 1, wherein we are going to take h as 0.1, x0 as 0 and all those corresponding values. Okay, so my x1 will be 0.1. So we are going to work for y of 0.1. Okay, we are going to work for this in this. Okay, let's see how to work. Now first of all, one key step you have to do is just work for f of x0 comma y0. So f of x0 is 0, y0 is 1. Is it? So how is it defined? How is f of xy defined? It is 3 times x plus 1 by 2y. So here the value for x is 0, value for value for y is 1. So 1 by 2, 1. So it is going to be 0.5. I hope it is clear. So the value of f of x0, y0 is 0.5. Keep it aside. Now I just need to work for y1 initial approximation. Just work for y1 initial approximation by Euler's formula. By Euler's formula, it is defined to be y0 plus h times f of x0, y0. y0 is 1, h is 0.1. Okay, and what is f of x0, y0? We have just now found it is 0.5. Now 1 plus 0.1 into 0.5 is 0.05. This value is 1.05. So therefore, the initial approximation for y1 is 1.05. Keep it aside. Okay. Now we are going to get we try to develop the accuracy by applying modified Euler's formula. So applying modified Euler's formula means what? First let us write y1 first approximation. y1 first approximation by modified Euler's formula. Here I am going to write modified Euler's formula. This is by Euler's formula. Okay, please make a note. So I have not written in the beginning, you can even write there. Okay, or if you don't write also, it is understood. Okay, so now y1 first approximation, it is going to be y0. Write the formula there. F of x0 y0 plus f of x1 comma y1 initial approximation. Now this is equal to, what is y0? 1. What is h? What is h? It's 0.1 by 2. H is 0.1, so 0.1 divided by 2. F of x0 y0 we have just now found, it is 0.5. Keep it as it is. Plus f of x1. x1 is 0.1. y1 initial approximation is 1.05. Write that as well. Or this is equal to 1 plus 0.1 by 2. It's 0.05. 0.5 plus, now how is f of xy defined? It is 3 times x plus half y. Okay, so it means what? 3 times x means 3 times 0.1 plus half times 1.05. Is it? Simplify this. 1 plus 0.05. Now this is 0.5 plus 0.3. 3 into 0.1. 0.3 plus, what is this? It's 0.525. 1.05 divided by 2. 0.525 you get. So this is equal to, just simplify this all of you. It's 1 plus, I'll do it in here. 1 plus 0.05, use your calci here. 0.8 means I can write this simplification as 0.8 plus, now see here, you can do one thing. Now this value of x1 is not changing anywhere. I mean, in the next iterative step also, y1 second approximation also if you take, it is f of x1 comma the next, I'll explain it in the problem in this. Okay, so just do put the values in your calci. The value should be value is 1.6625. The value should be 1.6625. This is going to be the first approximation. Now let us work for y1 second approximation. Use the formula again, y2 plus h by 2. Because it has been said in the question, perform 3 iterations in each step. So we are going to work for y1 third approximation and then we are going to switch to the next stage. Okay. So most of the time it will be mentioned. If it is not mentioned, it is better to do up to 3 approximations or 3 iterations. It is safe. Your marks will not be deducted. Okay. So better if you go for the third approximation even if it is not mentioned. Okay. So it is y0. y0 is 1 plus this value already we have written. And this value also we know it is 0.5 plus f of x1 is 0.1 comma y1 it is 1.06625. Is it? Okay, now when you simplify this further, it is 1 plus 0.05, 0.5. See here, everywhere there is 0.1 only. So it is 3 times 0.1 only, no? So you will get 0.8. Directly I can write 0.8 and this value divided by 2 I have to add. Okay. So it is the way you take it. Okay. Otherwise simply you need not write all the time this whole thing. Okay. You can just skip it or you can just make it in short. Okay. By just remembering few key steps, like for example it is 0.5 plus 0.3 all the time. In this formula also it was there. Next formula also it will be f of x1, no. So it will be 0.5 plus 0.3. Okay, I will directly write. So it's going to be 0.8 plus the simplified value for this is going to be, see, it's 0.8 plus this value divided by 2, no. And if you put this in your calc and evaluate, you will end up with 1.0667C. Similarly, y1 third approximation, it's going to be y naught. Let's first write the formula. F of x naught y naught plus f of x1 comma y1 second approximation, recent value we are going to use. Okay, so this is 1 plus 0.05 into 0.5 plus 0.3. This is going to be this value divided by 2. Okay, and if you just put this in your calc, you will end up with 1.60667. So for 2 successive steps you have got the same decimal values. You are going to consider up to 4 decimal places at the end. Okay, so I hope this is clear to all of you. So this is going to be y of 0.1 is equal to 1.0667. Okay, take this as the final answer for the stage 1. Okay, now we are going to continue with the stage 2, taking this as the initial condition, because in question it has been asked to work for y of 0.2. So let us work for y of 0.2 in the coming stage. Now let us continue with the stage 2. Final answer for that previous stage was y of 0.1 to be 1.0667. This was our result. Okay, we are going to use it in our this stage to continue and get the value for this. Again, h is 0.1. Here your x naught will be 0.1. Okay, so your x1 will be x naught plus h. So that results in 0.1 plus 0.1, which is 0.2. Okay, and y naught, it is 1.0667. Okay, that is this value. This is going to be, so means what? The previous stage value, you are going to use it as the initial value for the next stage. Only that is this you need to do. Okay, rest everything is same. Whatever we have done there in the previous stage, the same will be continuing. Every step is going to be the same, but with these new initial values. Okay, that you should remember. So now again f of xy. F of xy is the same. Okay, so we are going to work for f of x naught y naught with these values. F of x naught value is 0.1 and y naught is 1.0667. Just work for that. It is 0.3. Okay, let me write in detail, otherwise again you will be, okay, 3 times 0.1, because as per definition it is 3 times x plus half times the value of y. So plus 1.0667 divided by 2. If you evaluate this, it should be 0.8, because this is going to be 0.3, this is going to be 0.5333. So 0.8333 you should get. Okay, just see all of you. After that, I'm going to work for y1 initial approximation by Euler's formula. Just see that 83333, again if it is 1, it's 5 here, sorry, you just take that 0.5335 you will get. 1 3 here, 1 3 here, 1 3 over here, and 1 will be remaining, so 5. Okay, so you will be having that. And then yes, let us work for this y1 initial approximation. Initial approximation for y1, by the formula it is y naught plus h times f of x naught y naught. Y naught is 1.0667 plus 0.1 times f of that value. F of that value is 0.833335. Okay, just substitute. So if you put that in your calc, you will get the initial approximation for y1 to be 1.15. Just check all of you. Similarly, now let us use modified Euler's formula. This is by Euler's formula. Okay, now I'm going to use modified Euler's formula. I'm writing in short, but please all of you write it in detail. Okay, so I don't, just to reduce my time. So y1 first approximation as per the formula, it is h by 2 times f of x naught y naught plus f of x1 comma y1 initial approximation. Do all this calculation in your calci. It is 1.0667 plus h by 2, it's going to be 0.05. F of x naught y naught, it is 0.8335 plus f of x1, it's going to be this time x1 is 0.2. See, so let us write f of 0.2 comma y1 initial approximation. So 1.15 here. So do this. So it is 3 times 0.2 plus 1.15 over 2. Substitute all the values in your calci and simplify that equation. The answer should be 1.1671. Similarly, let us work for y1 second approximation. Use the formula. So x1 comma y1 first approximation you are going to use here. So its value is, substitute all the values. H by 2 already I know, so I'm not going to simplify it again and again, just keep the values directly. This is 0.8335 plus x1 value I know it is 0.2, but this time the new value for y1 I have to use, that is this, divided by 2 I have to do. So it will be 3 times 0.2 plus new value for y1, it is 1.1671 divided by 2c. Okay, now when you simplify this, you will get 1.1675. Just check all of you. Similarly, go for y1 third approximation. Use the formula. Substitute the values. y1 second approximation this time. So these values I am going to directly substitute. I hope you will get used to it when you start working. So this is going to be 0.8335 plus 3 times x1 means it is 0.6 plus the new value for y divided by 2, that is 1.1675 divided by 2 you should do. Okay, do it. At the end you will end up with 1.1676. So therefore y of 0.2 is equal to 1.1676. This is the required result as asked in the question. Okay, so this completes the solution by using Euler's modified method. Okay, if you still want one more problem to be solved on this modified Euler's method, I'll work for that. And one more thing, if suppose it is not mentioned in the question about h is equal to 0.1, okay, if it is not mentioned, then directly you can take h as 0.2 and get the result, the final answer in just one stage. Okay, you need not work for 2 stages like how I have worked, because it was mentioned I had to go for 2 stages. Okay, look at that. Initially x was 0 and we had to work for x is equal to y of 0.2. Okay, so the difference between the given value of x naught and evaluated, this was 0.2. Okay, so the difference was 0.2 there, but still we were asked to take h is equal to 0.1. So definitely we have to go for 2 stages. If it is not given h is equal to 0.1, you can directly get the value for y at h is equal. One problem of that type, if you want, I will solve it. Okay, continue in my next class. Thank you.